We've got 4 of them. Pong. Welcome to welcome to the last meeting of this IETF second routing working group meeting. And so, next slide, please. So hopefully by now it's Friday. You should know not well. If you didn't know it on Tuesday, sorry.
We still need to show it. Right?
Yeah, we need to show it. Please be aware of IETF rules, and we take anti-harassment policies rather seriously. We won't tolerate any inconsiderate behavior. Please respect each other. So agenda for today is Young QS. So again, we believe it's really, really close to working group last call. Potentially this is the last update before that. So NetCloud problem statement, we've been working with Linda on improving readability of the draft. We believe there is still quite some work to be done on this, but authors are actively engaging with us. And
sorry, I think I forgot to update this agenda. So the sequence need to be adjusted. The protection series will go after the QS model and then the cloud segment update. The cloud and the multi-segment SD1. So, because Huanmo has a conflict with another working group, so we're going to let him go first.
So we are having a number of kind of core routing working group items on protection. So egress, midpoint, and considerations for protection in general. Then Linda will talk about transport-aware mobility. This is the work that's progressing in DMM. So they're looking at extensions here, and then we'll get quick update on APN. So yeah, that's the thing for today.
So if anybody have any comments about the agenda, please speak up. Otherwise, we'll get the presentation started.
And to provide update on side meeting. So the attendance was great and we received a lot of positive comments. So we plan to continue with somewhat educational efforts, but also going in depth. So expect additional meeting in Prague. We'll be working on content for you. We'll also get people who didn't get to present because of technical issues. So Tencent and China Telecom to present in Prague.
Yeah, but we do have other slides available in the GitHub, so you are welcome to go download or take a look.
Yeah, and recording is somewhere. We still don't know where it is. Hopefully we'll find it and upload to GitHub. Mahesh?
Okay, so this should be a relatively quick presentation. Next slide, please. All to say that we have done, finally, we did take care of all the Yang doctor's comments. They were quite extensive. Thanks to Jürgen for that. We did add plenty of examples, including one for scheduling configuration. So we believe now we have a sufficient number of examples in the model for all possible configurations. Next slide. So at this point, we believe that the draft is ready for a working group last call. We would recommend that, I think, since we had received extensive comments from the Yang doctors, that we do another working group last call, Yang doctors review.
Yeah, so this part of last call procedure, we will do IETF-wide request for review. Young doctors, one of them.
Okay, excellent. especially like Jürgen to take another look since he had a chance. So if when you put in the request, you might especially
Okay.
ask for
Will do
him.
so.
And of course, Obster might also be interested in a review. So definitely have them take a look.
So they are all young doctors, right?
Um,
Who is the second reviewer? You said you want to take a look.
Jürgen.
Jürgen.
And the other one?
No,
Cecil
so it's
Elf.
Jürgen who had done the initial
Yeah, I
review.
know, yes.
So I wanted him to specifically take another look at it.
Okay.
Next slide, please. All right. So as far as this is the GitHub location where we track all the issues related to the draft, we finally whittled the count down to 0 by taking care of the examples, the editorial changes, and the prefix renaming. I think that request came from Tom Petch. So that's pretty much it. Any questions? Thanks.
So I would like to thank authors. I know how complex it is to align different QoS schemas because everyone has implemented something different. Really great work and shows how IETF should do things.
Thanks.
Thank you.
Hello, everyone. Today I'm going to talk about SR phase 6 pass egress protection. Next page. First, I would like to thank AC, Peter, Bruno, Yimin, Jeff, Zhenqiang, Chris, Alex, Ketan, Greg, Jay, and Bob for their comments and suggestions. So the latest update to the previous version includes reducing the number of authors to 5. In addition, mentioning route retention in normative sections. In the previous version, we talk about route retention in examples. So as Bob suggested, and then we may also mention this route retention in the normative sections. Also, we made some editorial changes. So let's summarize some progress during the last couple of years. Next page. So since IETF 112, we present and ask for working group last call, and we are suggested to get comments from Sprint and LSR. So after that, we requested comments from Spring Group and LSR, and also appreciate AC. AC reviewed this one in details and gave us very valuable comments. And then we update document, present those that document to LSR. So at IETF 115, we presented the updates to address the comment from LSR in the RTGWG. And then we are suggested to get more comments from Spring, and then we sent request to Spring list. And then we got comments from Spring, we update document, and then we present those updates and the whole solution to the Spring. And that's in IETF 116. So next page. So this is what we present in the Spring Group. Basically, we print updates and the whole solution to the Spring Group, and then try to get more comments. Next page. And then I think we get all comments addressed, and then maybe any new comments are still welcome, but we also would like to have a working group last call for this one.
Any questions, comments?
So for this document, we have requested directorate early reviews So we hope the working group can also review this document before we start the working group last call.
That's all.
Okay, next page for next presentation. So this is about SR6 plus midpoint protection. So next page. So I'll report a progress since IETF114, and then just list the comments we get from Spring in the last IETF. Next page. So in IETF114, we ask for adoption, and then we are suggested to get a comment from Spring and 6man. So we send a request for comments to those groups, and then we get a lot of comments, and then we address those comments. So in IETF115, we present the updates in the RTGWG, and then after that, we still send a request to Spring Group and S6man for get further comments. And then we also summarize the comments we got. So in last IETF, we presented the whole document, whole solution to Sprint, and then try to get more comments. So next page. So this is what we present. We present the updates and then the whole solution for the midpoint protection. So we don't go through details for this one here. Next page. So this is the list of comments we get from Spring last meeting. So these comments all will address these comments, and then I think so for the last few comments we also addressed in the next page. I'll show you the next page. So basically, a couple people suggest that we should merge two documents, because in Spring we already have a working group document for SR MPLS midpoint protection. So people suggest that we should merge that one because that document have a solution. They call the real side tunneling to resolve some problems, and then some compilers should be preferred. And then another person suggests that SR fix is simpler, and then the authors of two documents should be work on merged version. So regarding to these comments, so I send the email to those authors, and then I'm open for merge, but what's their opinion? The reply I got is that they don't want to merge. So in this case, I think no merge right now. So next page. Since I have no merge, and then maybe we can move forward for this document. Still, comments are welcome, and then I would like to request for adoptions. Thank you.
So a couple of comments. The number of times you've presented the draft are not the leading kind of factors for adoption of document, right?
Yeah, I know. Yeah,
so
yeah,
in this
right.
case, perseverance not necessarily the good thing.
Just to summarize what we did. Yeah, I understand.
Yeah. So the merge is, so this document is progressing in working group, right? If working group thinks that it should be merged, probably you as editor should be working with co-authors to find a solution that is, that is according to working group opinion on the draft.
Yeah, I'm still open for the merge. Yeah, no problem.
So before we think about adoption, you really need to address the issues that have been raised. So merge is one of them.
Yeah, I think all the others should be addressed. We can go to the details in the list or whatever.
Okay.
Okay.
Hi, Yao from ZTE. I think I'm not sure whether this question has been addressed in the mailing list, but I'm not seeing it. I think there's a scenario that this mechanism isn't applicable. So, because in SRv6, it is only the endpoint then can modify the SIH, right? So imagine there's a scenario. You have node A, B, C on the path, and the segment list is adjacency set on node A for link AB, and node set for node C. So if node C fails, node A don't know this because the link AB is good. So the packet is sent to node B with the destination set to node C. And because node B is not an endpoint, so he can do nothing. So in this case, I don't think the midpoint protection will work.
I think we talk about in the draft, and then only endpoint will do the work.
Yeah.
So only endpoint just change the segment left, the point. So we don't touch this inside. So I think this some kind of issue in generally we already addressed. So if you have issue, I think maybe you put it in the list, give more
Okay,
detailed
okay.
descriptions, and then we can just address that in the list.
Okay, thank you.
Sorry, I have some trouble raising hands through a system. Can I give comments?
Absolutely, go ahead.
Yeah. As co-author, I want to respond to the previous question from Liu Yao. Actually, this has already been addressed because there is a really long time ago, there is comments from Bruno. He mentioned that the transit node, if conduct this kind of behavior, it's kind of a violation of RFC 8200. So it's we have removed this transit node behavior. Just this kind of protection just happens in the endpoint. So I think this has already been addressed. And the second comment is that we have, as Huaimo mentioned, as we have already tried to communicate with other authors from the other document, and it seems like the author think the other document about MPS scenario midpoint protection is quite mutual. And I also try to talk about this issue with Spring Working Group chairs. They also think because the SRv6 data plan and MPS data plan is quite different, so maybe these documents can be processed separately. So we think the comments have been addressed, and maybe these two documents can be kept as independent documents. So we think the document is, this document is ready for working group adoption.
So I don't think you converge. Go ahead.
Yao again. I don't think that this addresses my question, because my question is not about whether this violates 82,000. It's about because in this draft, in the version, you remove the you have to follow 82,000. So only the endpoint can modify the SIH. And in the scenario I described before, in some scenario, because you are not an endpoint, you can do nothing about the SIH, so you cannot protect this scenario. I send the scenario to the list, so hope you
Please
can
do
explain
so,
it.
and
Thank
please point to specific text in the draft that, according to your opinion, doesn't satisfy the requirements. Okay? Thank you. Jim?
So Jim Guichard, no hats on. I don't remember the details of this particular document. I've got so many documents going through my head right now, but what I will say is that the comment about it's certainly true that you cannot modify the SRH, but there's no issue in terms of re-encapsulation. So if you're doing re-encapsulation, then there is no issue here from a RC perspective.
Yeah, then you don't violate it 200.
Just a very brief respond to the previous comments. Actually, if we just remove the transit node behavior, that means that that kind of scenario has been removed from the document. So we think, as my perspective, that kind of scenario cannot be solved by the existing document. That means that the scope or the scenario we want to solve has already been narrowed to the allowance of RFC 8200. So we think it has already been solved.
Thank you. Let's take it to the list.
Okay, thank you, everyone.
Thank you.
So for people on site, please remember to sign in by scanning the QR code over there I don't think everybody here signed in yet, including you. So the next presentation will be protection for consideration for protection of SR networks.
Hello?
Yes, we can hear you. I pass the control to you so you can control the
Okay.
slides.
No.
Please go ahead.
Thank you. Okay. Hi everyone, I'm Yisung Liu from China Mobile, and today I will present the considerations for protection of SR networks on behalf of my co-authors. And this is the overall structure of the protection of SR networks. First of all, for first level, we have two parts. For the path protection and the egress protection. For path protection, we have the local protection and the E2E protection. For local protection, with the RFA or TRFA or macro loop avoidance, and by the detection with the limit check for the BFD for interfaces or neighbors. For the E2E protection, with the candidate path hot standby and the B backup for T by the detection liveness check for the BFD or SBFD for SR policy. For the second part, egress protection, we have the local repair and the ingress node switch over based on the service FR and by the liveness check BFD for the egress seed or IP. The draft state we have updated to the 01 version after last IETF. We have rewritten the section 4 and with the deployment for the single home scenario and the multi-home scenario. And we also add the recommendation for the BFD configuration. We have added section 5 for the considerations for the SR6 segment list compression. Discuss the impact of SR6 segment list compression on the protection and the TRFA and with the CC and the macro loop avoidance with CC. Here are the protection deployment for the single home scenario. We use the TRFA as the local protection and use the multiple candidate path switchover as E2E protection, and also use the BE backup for TE when the both the primary and the backup candidate paths fail. And for the protection of SRBE traffics, we use the TRFA triggered by the BFD for links and neighbors. For the protection of SRT traffics, there are several cases. For the high SRA cases, we prefer to use the E2E protection. Only use the candidate path switchover that can achieve the requirement of the SRA. And for the faster traffic restoring cases, we prefer to use the local protection. So firstly, the TRFA triggered by the BFD for links and neighbors, and then the candidate path will also switch over and triggered by the BFD or SBFD for the SR policy. And we also use the B backup for T. When the multi-point fail faults, like both the primary candidate path and the backup candidate path fail. For example, in the fig, when the link P1 to P1 and the P2 to P4 both fail, so we can still forward the traffic from the P1 to P3 along the SRBE path. So the exception for that, if the traffic need a very strong SLA requirements, we prefer to drop the traffic. And this slide shows the protection deployment for the multi-home scenario. And for each egress PE, same as the single home scenario, we use the TRFA as the local protection. We use the candidate path switchover as the E2E protection, and use the BE backup for TE. And additional mechanism for this scenario is that the ingress node switchover we will monitor the liveness of the egress nodes by the BFD for egress nodes or the validating IGP rules for egress nodes if in the single domain. The head node will switch over among the different egress nodes. For example, when the P3 fails, P1 can switch from the policy to P3 to the policy to P4. So this slide shows the some recommendation of the BFD configuration for the time interval. For example, if we want to achieve the local protection no more than 50 milliseconds, we can configure the BFD for the links and the neighbors with the time interval 10 milliseconds and with the 3 times. When we want to achieve the end-to-end protection no more than 300 milliseconds, first the trigger of the candidate path switchover, that means the primary candidate path down, we configure BFD for the primary candidate path for the 15 milliseconds for the time interval and 3 times. And trigger of the BE backup for TE, that means all the candidate paths down. We configure the BFD for backup candidate path with the 100 milliseconds for the time interval and 3 times. So you will want to use the egress protection. We we recommend the BFD configuration with the 50 milliseconds 3 times. When the SR6 segment list compression is enabled, the repair node will check the compression capabilities of the nodes along the repair path and try to use the CC to encode the repair path, like in this fig, with the next CC on and replace CC.
Are you there?
Sorry. My network is not stable. Sorry. Can you hear me now?
Yeah. Please continue.
Okay. Here are the micro loop avoidance with the CC. And when the S16 segment list compression is enabled, the converging node will check the compression capabilities of the nodes along the post-convergence path and try to use the CC to encode the path with, like in the fig, we use the next CC and then replace CC. So here are the running code status and the we have done the lab interop test in the China Mobile in 2021 and 2022. Multiple vendors have passed this SY6 protection interoperator tests with the China Unitex, Huawei, H3C, DTE, and Ruijie. Both the single AS and inter AS scenario have passed the testing. And for the deployment status, we have choice of SY6 in fiber branch networks in China Mobile in 2021 and 2022, and with the Beijing, Zhejiang, Fujian, Guangdong, Henan provinces or cities. So we'll welcome more questions and comments. And this is a informational draft. We would like to provide some suggestions for the SR protections in networks. So now the considerations of this draft, we think it's relatively complete, and we want to ask for the adoption call. That's all. Thank you.
Any questions, comments? So in general, in the routing working group, we are all for informational documents and deployment experience. However, looking at the draft itself, it's a single provider and two vendors, right? So we would really like to avoid something that's very specific to particular deployment or particular implementation. So there's a number of operators on the list. This Verizon, Deutsche Telekom, and large tier ones, right? It would be really good to socialize this document with people who are actually using it and see whether you agree on how the technologies are described and whether they agree with use cases. And so we would like to make it as much as useful for everybody else. So compared to RFC 7938, you read it, you know how to build stuff. So the intentions here is pretty much the same, right? It's informational and you share your experiences. Would be good if this experience are shared by a larger group of people than just one company.
Okay.
So please go to the mailing list and actually solicit solicit for more experiences, more text, because obviously you're not the only company trying to use these technologies. That would be the next step from my perspective.
Okay, thank you.
Thank you.
Okay, my name is Linda Dunbar. I would like to give a summary of this network to cloud problem statement and mitigation methods. Thanks to the working group chair, started the early review from all the directorate, and I'll give a summary of the major comments and major changes. Okay, next page, please. Okay, so just refresh people with the problems, key problems. This draft actually has been in IETF for a long time, started in 2017. We then identified the network to reach to the workload in cloud and address several problems. And the goal was try to identify what kind of things IETF can do and will do. And very fortunately, through all those years, many of the IETF drafts have been created to address some of the problems. So this draft basically document all the problems, why we need this, and here are some of the mitigation methods. So the first problem is with connecting to the cloud, there's always eBGP sessions. Unlike with service provider, traditional service providers, where you have a pre-agreed agreement on the peering policies, with a cloud provider, the peering can be temporary, or there are many, many more. So there could be problems of policy not set up right. There could be more than desired prefix coming in. So today's method is always auto-banned through the syslog and reporting to the management system. It can create some problems when the peer is not aware of they are sending more than they have agreed upon for the maximum number of prefixes. So for that problem, we have gone to IDR working group, worked with many people, and learned that it's not really easy for IDR to BGP to have an in-band message to the peering. There's lots of historic reasons. People don't want to do that. I've talked to quite a few people. The working group chair, IDR chair, has told me that in the past there were many attempts to do that, but none of them succeed. Maybe things change. Maybe we'll see. So today, still the method is through the syslog to the management system. Another problem is um, as a cloud side, there could be a large number of routes being impacted by, say, a fiber cut or because of a loose power. So you could have large number of routes being impacted. The traditional method is for the egress node to send many routes withdraw, but there'll be a lot of them. So there's new draft, not new anymore, to indicate the site failure. The site can be a pod, a building, a row of server racks, and be able to indicate one single message to tell the ingress node, all those routes being impacted. So that's the problem, and in IETF, we already have a method to mitigate that problem. Another one is in the cloud data center, there could be one service could have many instances instantiated in different sites. And sometimes all those sites are not too far away from each other. So the shortest distance, the distance-wise, the difference is very minimum, it's trivial sometimes. So there will be the processing time may be more determining factor for low latency. Also for that, we have methods to mitigate that, be able to allow the egress node to propagate some of the matrix associated with service instance, like processing delay prediction matrix to the ingress node. And another problem is for the cloud applications. Sometimes you want to be able to have the topology based on the application ID instead of the service, the IP addresses. So with that, we also have a draft, is a working group draft to describe specify the solution and mitigation methods. Next. Okay, so another problem is to connect to the on-demand cloud-hosted workloads. There will be DNS issues, especially for enterprise. They may have some workload in cloud A, another workload in cloud B. The DNS resolution can be an issue when the particular one cloud provider cannot resolve that. So in the draft, it describes some of the methods to mitigate that problem. Another problem is identified in the draft is the cloud discovery. When you have multiple service instances instantiated in different places, what are the methods to discover where your service instances are? So we also have a draft to address that. This is a working group draft already. Next page. One of the problem is for the cloud interconnection, you could have service instances far apart, enterprise sites far apart, and the IPsec point-to-point pairwise key management can be an issue because when you have large number of pairs, the pairwise is not scalable anymore. So in the document, it describes some of the methods to mitigate that problem. Also, we just had a new draft, which will be presented later on the how do you connect multiple sites through the cloud backbone that we call multi-segment SD-WAN. Okay, that's the key problems and mitigation method practices described in the document. Next page, please. So this document has gone through the director reviews from different areas. Thanks to many people who provided comments and suggestions. The document quality definitely improved a lot. So here are some of the major comments. I just want to give people an update on the major changes. So from a TSV area, major things they wanted is to include the congestion notification into the solution mitigation method. So that has been added. In the RTG area, there's the major comments are about the 5G deployment impact to the issues, and also okay, so the security area is adding the security impact, and also that to make it clear that the IPsec is actually very secure, even though from management perspective, it is cumbersome and not very easy. So those are the next page, please. So for the DNS ops and DNS directory, they also gave some of the major comments. So here are the major bullets and operation area. I want to thank many, many people for making suggestions for the wording improvement. And so that's the major changes from all those directory reviews. Last one. So I think that with that, this document is ready for working group last call. Thank you.
Thanks, Linda. So a lot of work, and I really appreciate you being on work, addressing all the comments. We still have some reservation about quality of the text wording, so we continue sending updates. And again, thank you for addressing them pretty much immediately. So you're on the right way towards working group last call. We are not there yet, so we expect some improvements, especially with regards to readability of the text. Okay, but we are working on it, and thank you for being active and responsive.
Thank you.
Yeah, we'd like to encourage the working group to really review this document, make sure it's to our satisfaction.
Okay, thank you very much.
Good afternoon, everyone. I'm presenting Kaushik Majumdar from Microsoft, presenting multi-segments SD-WAN by Cloud DC draft on behalf of my other co-authors. Okay. Yeah. We can go to the next slide. Yeah, as a short intro, all right, the cloud provider provides the SD-WAN connectivity, connecting on-prem CPEs with the enterprise-owned application and third-party SASE-based services in the cloud DCs. And there are multiple options, like when enterprise come to the cloud DCs. So some of the models described here. The first is direct interconnect model. That's the diagram shows like how the direct interconnect model works. So in this case, the on-prem CPEs connect to the cloud virtual hub, and that's facilitate kind of connecting to the different spokes to the workload access in the cloud, and kind of facilitate the traffic going to the destination branch CPE. So this is one model. The second is the direct interconnect model with the enterprise's own virtual appliances. The enterprise brings their virtual appliances as a VCPE and hosted in the cloud, and that act as a gateway when connecting the different branches. The third is a combination of two, the indirect interconnect model via SD-WAN path. The diagram it's not showing here. The diagram is mainly for the first model, but in the third model, We have both enterprises virtual appliances, which is on the NVA, act as a NVA in the enterprise VNet, and the other VNet, we have a virtual hub where it will be connected via SD-WAN path, and that way they will have connections to the all the workload, and the traffic would be routed through that like a enterprise virtual CPE or the NVA to the other branch location. So that's the third combination. The fourth is managed hybrid WAN model using enterprises existing VPN connections. So the manage, it comes the enterprise connect to their managed service provider, um, nearest managed service provider, and then the VPN, they provide the VPN connections, and from there they enter to the cloud backbone. So these are all four different models, and if you need the details we can talk offline. But all these models today, the when the traffic comes to the cloud, it gets terminated, the IPsec tunnel for the SD-WAN traffic, it gets terminated, and we reinitiate a new tunnel to the destination CPE. So this draft proposes a method to connect multiple SD-WAN segments between the cloud gateway and the enterprise CPEs without the cloud gateway terminating the IPsec tunnels. So next slide. Yeah, so I'll go over the two different scenarios before we get into the solution details. The first scenario is branch to branch traffic via single transit gateway within the cloud DC. So here the branches or the CPEs are co-located. So they are connected to a single cloud gateway closer to their region, and that basically between the CPEs they will have a, since it's a belong to a certain vendor, so like it will be having a IBGP sessions between them, but within the from the CPEs to the cloud gateway they will have a EBGP sessions. They can always configure the manageability portions through the cloud provider um, well-defined APIs. So the benefits why the traffic will go through the cloud gateway, that benefits are listed here. The public internet between the branches maybe have the unstable connections and prone to cyber attacks. But when it goes through the cloud, they will have more reliable connections, and the traffic would be monitored by the sophisticated network functions. Second is easier to use the cloud-based security functions such as firewall, DDoS, and apply constant policy enforcement on for accessing the workload and services. Also, the cloud-based tools and SaaS would be used to collect and analyze the threat of the traffic. So these are the kind of multiple reasons the traffic comes to the cloud and goes the branch-to-branch traffic follows through the gateway. Next slide. So this is the extension of the first slide. Like here, the branch to branch traffic is connected via cloud backbone. So on a geographically far away branches can establish the SD-WAN paths to their corresponding cloud gateway to access the cloud services in different locations. But when they try to send the traffic between them, the traffic goes through the stays in the cloud backbone. They crosses multiple regions within the cloud. So again, the branch CPEs would be connected in the IBGP sessions, and that the CPEs, the source CPE and the destination CPE should be connected over EBGP sessions to their respective cloud gateway. The destination CPE could be connected to a even multiple egress gateway CPEs for the redundancy reason. That's always possible. The benefits, obviously, the traffic stays in a cloud backbone and the SLA would be kind of maintained. So all the benefits also carries over from the single cloud gateway deployment scenario. Next slide. So those are the typical two different scenarios. Now the solution wise, this is the illustration of the IPsec flow traffic through single hop cloud gateway. So the key proposal for this draft is to use the Geneve. Geneve header indicate cloud transit informations, and the Geneve is have a wide adoptions in the cloud service provider. The sub TLVs carry as a metadata informations and provides the lot of flexibility. So as you see in the outer IP header, gives the source CPE's address and the destination cloud gateway where it is the source CPE is connected to, that it already established. Then it comes the UDP and the Geneve header, followed by a new multi-segment SD-WAN option class. Then we'll have a mandatory SD-WAN endpoint sub-TLB, which carries the actual destination CPE's address. Then we have a payload, the customer packet, which is encrypted and authenticated. So the cloud gateway, the transit gateway, they don't need to touch the inner packet or the payload. They don't need to open. They just act on the outer packet and process the Geneve header to find where the destination of the packet. So next slide. Yeah, so here is the little more details of the Geneve header with a option SD-WAN, multi-segment SD-WAN option class. 3 sub-TLVs are proposed here. The first one is mandatory endpoint sub-TLV, uh, which kind of provides the destination CPE's address. The second is optional, the originator sub-TLV. It carries the originator address. The third is the egress gateway sub-TLV. So these are the 3 different sub-TLVs currently proposed. Next slide. So the endpoint sub-TLV has the TTL field where it can set the TTL, and it would be decremented through the transit nodes. So when that packet reaches to the destination CP, that has the flexibility to know how many transit node it traverses, or it can also set the max limit. The origin endpoint sub-TLV would give a flexibility for the initial cloud transit gateway to apply certain policies while the traffic traverses through the cloud backbone. Next slide. The egress gateway sub-TLV, again, it would be where that destination CPE is connected to their respective egress gateway. That informations could be propagated to the source CPE through some control plane mechanism. And there might be a possibility for the redundancy reason, the destination CPE might be connected to the multiple egress gateways. So they can include, the source can include that multiple gateway sub-TLV. So there is also an option we haven't defined, but there are 2 different additional sub-TLV is proposed in this draft, which is include transit sub-TLV and excludes transit sub-TLVs. So this gives an additional flexibility for the enterprises to specify if they want to, for the traffic to follow some specific region within the cloud backbone for security reason or comply with the regulations, they can always do that. But that might be an enhanced feature. And then we have the similar exclude transit sub-TLVs. Again, the enterprise can include in this sub-TLV the list of regions want to avoid for security threat or comply with the regulations. So these are the options. Next slide. So that's pretty much. So at this is the first versions. I would kind of we would look feedback comments in the working group, and as if anyone from the vendor sides interested in joining this work, please reach out. So I'll stop here if there is any questions. Thank you.
Thank you. So a few comments here. You don't need to address them. So I'm happy about this work in routing working group. It's a real problem, and I recognize it. I've seen it myself before. It's good that we are trying to look into protocols that IETF identify as the NVO protocol rather than trying to show it again into BGP. Right. So I would really like you to reach out to NVO folks so they would look into Genève part encoding and the efficiency of the encoding, potentially also talking to security folks.
Okay. Yeah, we have appended the, we have initial review done with the security ops team, and we have put some kind of in the appendix sections, like two options. Like if you just quickly go to that one, or do you have a time? There is appendix sections followed by this. Yeah, so this is the first options. There is options based on the review with the security team, ops team. So we can always, there is a choice. The vendor can always include that AH header followed by IP header, and that can carry the authentications of the full payload, including the outer IP. So that is there, but this helps if there is a man in the middle attack. But the drawback is in that case, that's every node in the transit gateway it traverses. It will the packets need to be kind of a, we need to have the new authentications need to be recomputed. The SPI value has to be changed. So that's the more, it will involve little more processing. So but there is a option, and second options, if you can go to the next page. Yeah, so the also we in the these options, it's kind of requires the PROs, the key management between the CPE and the cloud gateway. Otherwise, maybe we don't do anything. The consequences anyway, the packet drop or the DDoS will kick in the cloud backbone and mitigate it. So those are the. I see.
There's a
Yeah.
question.
So there is one person in the queue. I really don't know how to pronounce your name. Please go ahead.
Hi, my name is Nihal Patel.
I cannot hear you. Please speak louder.
Can you hear me now?
Still not.
How about now?
A little bit louder.
Any better?
Little better.
Better?
Yeah, a little better.
Sorry, I'll try my best. Yeah, so I represent large enterprise space, Johnson & Johnson Consumer Healthcare. And in the past, I've also...
It's impossible to hear you.
Maybe you can send the question in the working group. We'll try to address there. Because
Okay,
it is little difficult to hear.
Okay.
Oh,
okay.
Thank you.
yeah,
Thank you.
you can contact him after.
Okay,
Yeah.
we'll do. Thank you.
Thanks for the presentation.
So okay, so this is the small draft, is to talk about how do we extend the transport-aware mobility from the 3GPP core network to the IP network. Next page, please. So a little bit background on this. In the DMM working group, there's a working group draft. How do we map the service identifier, the requirement into the network slices? So there's a DMM TN aware mobility draft. So however, that draft only addressed the network issue from G node B to UPF within the 5G core network. For services, to ensure the service end-to-end quality,
the service has to be, the quality has to be ensured all the way to the destination, which usually is in a data center or is in somewhere. So this draft is just extend that characteristics into the IP network. Next page, please. Basically, for the 5G service, there's a 5G service management entity, which indicate the service quality requirement. And from there, they have input into the GNOB, the 5G network service management, to indicate the service quality. From there, the DMM working group draft is recommending mapping the service into the source UDP port, so that on the GTP tunnel, outer tunnel, they can have the source UDP port to represent the quality desired. With that, they can map into the IP network. And so similarly, the 5G management system can notify the network controller to notify how do we map from the UPF, the 5G's UPF, into the ingress router. Okay, next page, please. So here's the illustration of the data transition from user device to GNOB to UPF and to ingress router. So basically, the UE traffic, user device traffic, once they get into GNOB, it will be encapsulated with GTP tunnel. And with the GTP tunnel, based on the service requirement, they map into the they arrange different range of UDP tunnels, UDP IDs to represent the quality. And from there, once it goes through the UPF, the similar indication can be carried over into the data network. So they just show the data transition, the packet transition from the 5G core to UPF and then to the CPE. Next page, please. So there are several options to mapping the TN-aware policy from the 5G to the data network. So they could be, if the data network is SRTE based, and then you can use the BGP SRTE policy, SAFI, to indicate the policy, which is already there. Option 2 is through PCE. Which is also already implemented. So these are just a method. It's possible. Also, you could have using the netconf or gRPC session to notify the mapping policy, which is already there. So the option 4 here is you can use the flow spec in the BGP session. Suppose if the ingress node has a BGP flow spec session with the controller, they can use the flow spec to indicate that as well. So for that, the IDR hasn't had that option yet. So we have a similar draft, companion draft in IDR to indicate how to use the flow spec to pass the policy. Next page. So here just the illustration using the flow spec. How do we map the policy from the source UDP port to the appropriate different transport paths in the data network? Okay, that's it. Next page. So this is another method, basically using the SD-WAN. Like how do we map that into different SD-WAN paths? We can use the method specified in the SD-WAN edge discovery draft. Next one. So this draft was published about 2 years ago, I guess, but we never get a chance to present here at the RTG working group. So we're looking for feedback, and it's a small draft and basically identify some of the methods which have been specified and how do we extend from the a 5G core into the IP network. So looking for feedback from the working group, and then we'll address from there. Thank you.
Any questions? Comment as a working group participant. So practically what you need to do is to map UDP source range into some identifier in a data network. PSEP doesn't allow you to do so.
PSEP doesn't allow?
No.
Okay.
So you really need to look into protocol means to configure mapping from something you copy from UDP header into identifier of a path in transport network.
Thank
So,
you for the comments. Okay, I'll change that in the draft. Thank you.
So we'll have the last presentation about APM problem statement.
Hi, can you hear me?
Yes, I can hear you. So, and I'll pass the slide control to you.
Okay, thank you. Hello, everybody. This is Shu Ping speaking, and today I'm going to briefly introduce you about the progress we made on this problem statement of APN. As you know, in the mailing list, APN mailing list, virtual team to craft the problem statement was announced, and 1 month after this IETF 116. And basically, we have got 17 people from different companies. I mean, besides the people who are listed here, there are also other people from different companies, and they have also provided very valuable feedback. So many thanks to everybody here. And basically, the virtual team is working to craft the problem statement, and we will try to describe a problem of interest and importantly, its value to this IETF. And also, we will also try to clarify the problem space to be addressed. Okay, so I will briefly go through the problems and we have identified. And basically in a network operator controlled domain, and it's a single network operator. And usually at this ingress edge devices, there are always very rich information, such as this VLAN or QINQ or VPN or access interface, those kind of information. And usually those information is used to classify the packets into these fine granular groups of flows at this edge. However, the problem is after those packets enter into the network operator's domain, all those information is not immediately visible and within the network. So they may be hidden inside the tunnel encapsulation, or masked by the encryption, or mapped into other fields, or completely stripped off. So especially for this mapping scheme, and some level of granularity is lost. For example, that those information is mapped into these small fields, like this DSCP is 6 bits, all this EXP for MPRS is 3 bits. So within the network, and the operator only have this relatively coarse-grained queues treatment. And so it's not very sufficient to carry what operators needs. And here are 2 high-level uses scenarios. And one is single domain, the other is multi-domain. But keep in mind, both of the cases belonging to the same network operator's admin domain and admin control. So first of all, this single domain. And we know that along the packet path and the packet treatment may vary at different parts. And they may have different treatments, such as steering, triggering, or identifying. And basically here, we want to find an efficient way to realize a composite network service provisioning method. And for example, along the path at the head end, and the packets needs to be steered into a corresponding path. And at the midpoint, and the corresponding performance measurement data needs to be collected. And over this service function, and those particular policies needs to be executed. And for the multi-domain case, and here we meant the multi-technology domains of a single vendor. And basically, in the real deployment, those domains are controlled independently. And sometimes there is no hierarchical controller. It's very expensive to have. And for each domain, they have their own SLA mechanism. So it's very difficult to achieve this end-to-end consistency in service provisioning. For example, if you want to visualize the performance end-to-end along the path across the domains, just because you don't have such information to indicate the granularity of the traffic flow you want to monitor across those domains. And normally the ACLs, you will need to deploy the ACL in the following domains edge devices, but those configurations are very complex and also dynamic. It's hard to manage. And here one more slide on these multiple domains. And here you will see is there are two domains. Each of them has its own controller. And there is no hierarchical controller. And each domain has its own SLA mechanism. And the ACL in the following domains normally is very complex and dynamic. And so when people do the ACL configuration, and the keys is based on the IP addresses, but those IP addresses may change frequently. So the ACL, the keys will just it's not work anymore. And so here we would like to have a very simple and stable ACL configurations here. And as I said before, there is no hierarchical controller, and they are always not deployed. Okay, so that is the problem statement we have currently summarized. And so here we would like to know about your opinions and to get your feedback and how you think about this problem statement. Do you think it makes sense? And how do you think about these cases? And those currently we also explicitly mentioned about these multi-domain technology cases and whether you have it in your network. And so we will welcome more discussions in the mailing list and more feedback. Thank you. Okay, so any questions?
Hi, it's Adrian Farrell. Thank you for presenting that again, Shuping. Several side conversations I've had this week prompt me to restate that this is not about making routing decisions within the network. This is about making packet treatment decisions within the network. And I don't know how we can make that clearer because I'm getting a little tired of restating it, but perhaps you could use red ink next time.
Okay, thank you. Yes, so it's not only about routing, and it's about policy enforcement. Thank you.
Sorry, but you just said it's not only about routing. Is it about routing at all? Is there any routing in this? I don't see it. I think it's just about the policy, the packet policy treatment.
About this traffic steering, is it somehow like routing?
So head-end steering I get, but within the network, is there any routing forwarding decision being made using APN?
So for now, probably it's only about the steering. I mean, quite close to this routing precise.
It might be quite close, but it's not quite it. So I think Adrian has valid
Yes.
point. Please be very specific about that. And so there's APN IETF list. You're welcome to join if you're interested in this work.
Yes, thank you.
It looks like we are done for this ATF. Thank you for being here, and we are looking forward to seeing you in Prague. Safe travel.
If you didn't sign in to the meeting, please do. So we get a relatively accurate people count.